bem-vindos e bem-vindes. Essa é uma proposta do projeto ProteGEEr, que está sob a coordenação da Secretaria Nacional de Saneamento, e foi, inclusive, um interesse demonstrado pela Secretaria Nacional de Saneamento, que acesse, para além das abordagens mais acadêmicas, também uma aproximação com os outros setores, o setor privado e o setor público, para que se fortalecessem todos os agentes e, dessa forma, a gente consiga implementar as políticas públicas de uma maneira mais rápida e mais eficaz. A empresa que nós estamos... alguém pode fechar o áudio, interferência. A empresa que nós estamos trazendo nesse primeiro evento é a empresa Eismann, que está aqui representada pelo Dr. Wolfram. Ele é uma empresa que tem mais de 70 anos no mercado, é líder de mercado no desenvolvimento de tecnologias, inclusive, e para além disso, é uma bastante interessante porque tem plantas próprias, inclusive na Alemanha, quer dizer, além de serem fornecedores de tecnologias, eles são usuários das tecnologias, e isso pode ampliar a nossa discussão e enriquecer no momento em que eles são os próprios, que eles sofrem a repercussão do mercado, sofrem a repercussão do tipo de resíduos e da aceitabilidade dos subprodutos gerados. Então, a gente vai iniciar, a partir de agora, a nossa comunicação vai ser em inglês. Se alguém tiver necessidade também, que a faça, e aí eu vou comentar com ele que a gente vai iniciar. Tudo bem para vocês? Bom, acredito que sim.
Okay.
Okay. Dear Wolfram, thank you very much for your time to share your experience with us. I would like to start the presentation. I have explained that up now we are going to talk in English, and if they have any question, they can do it whatever they want. They don't have to end off your presentation. Is it okay for you?
Yeah, it's okay. For your information, I have two presentations. The first presentation is about the complete company, and in the second one, I would say something more to biological processes from our company, anaerobic, aerobic processes, and drying, biological drying, and so on. We can show to the presentation. In the first, I say something to our group. The company Eggersmann was founded in 1951. It's more than 17 years. We have more and more work in this company, more performance. More than 200 million euro in the last year, and we make it with 840 employers in this time. The company is staying in Germany in the most, and we have some sites for our company. We have some business units. It means we say we have a red area. It means the civil construction area. We see some example is companies for a little bit special work. When we have the green area, it means that we have composting plants by ourselves, and we can work with our technologies in the first time in our own companies. And when we have a big recycling technology and smart, we have many parts from this. In the first, the Eggersmann company for plant building, and when we have some other, we see it.
Dear Wolfram, are you showing something? Because you're are you showing some PowerPoint? 9.
It's PowerPoint.
We're just seeing your about some river, but we are not seeing your
sorry.
bildschirm.
You see it not, no? Okay. Sorry. It's better,
oh, yeah.
No? Okay. Then,
okay, yes.
Okay. Yes, that it means we have a performance in the last years from 100 million 12 years ago to more than 200 million in the last year with 800 employers. Sorry. And here we see the companies from Eggersmann. It's not all. We saw a picture in the next time for the civil area, for our company, composting companies, and also for the recycling part. Here you see Mr. Eggersmann and Mr. Hein were the CEOs from the company, and he is the owner. Here is one plant from us in the middle from Germany. So in the construction, it means the civil part, we build recycling plants, we build factories and schools and so on. You'll see something. It means it must be a little bit special, no? For us, a little bit difficult. So when we have apart from it's the name is betoned, it's for aesthetic concrete elements. You see it here, and this is a hotel. We have a hotel from our company. We built it, and we are the owner from this hotel. And we have also facility management for schools, for recycling plants, and so on. So when it's important, we make the composting in our plants with fermentation, with composting and biological treatments. So, and here you see it's in the middle from Germany. We have plants for the treatment from biological waste from 1.7 million inhabitants. Here, for example, this is one plant in the town Gütersloh. We have it 20 years and then build every year a little bit more in this area. And that's a plant with a fermentation step, or in the first step a mechanical step. The second is fermentation. Here's a rotting step, and here's a other rotting area. And apart from the recycling, we have the technologies from the company Eggersmann for plant buildings. We have the company Bacon. It means the company Bacon make the anaerobic systems. In our company Eggersmann Anlagenbau, we make the mechanical treatments for big plants and also all other biological technologies. When we have a lot of machines by ourselves, it is in the system technology from BRT and company Hartner. It means that we build by ourselves screen trams, wind shifting machines, ballistic separators, and so on. All what you, the most, not all, the most what you need in a recycling plant is built from Eggersmann by ourselves. And also we have mobile machines, shredder, screen trams, and so on. We show something in the next. For the Eggersmann Anlagenbau, for the building from plants, I think it's an important step to make in the first step, the planning from the complete plant. It means we have questions from all over the world for recycling plants, but it's not the same in this. It's different. We have different waste. We have different goals. We have not the same tons in a day, and so on. And when we must do in the first step idea for a flow sheet for the goal from the plant and so on. The next is we have by ourselves the development from this plant and the production and quality control in by ourselves. We make the assembly from and installation from this plant, and very important is more and more the control from the complete system. Here you see a plant in Poland. We can be, Eggersmann can be a general contractor for this. In this area, we have built the landfill in here. We have built all buildings, and we have made the mechanical treatment, the biological treatment, and so on, complete from Eggersmann. The next you see some examples. Here's an example in Germany for treatment for RDF. This is a sorting plant in Germany with the newest technology. More than 50 optical sorters are in this plant. We make plastic in different kinds and so on. The other example is a plant in Bulgaria, in Sofia. For example, in this plant, we have delivered 149 conveyors for screen drums, for air belt separators, and some other. In the next, you see a little bit from this plant. It's not all. It's only a little bit from this part, and here you can see some picture from the erection from this plant. For screen drums, the conveyor technology, we make all conveyors by ourselves. Also the steel construction. This is the other plant in Poland. So this is a plant in Middle East, also for material for incineration. Input is more than 500,000 tons in a year MSW. And we make 160 tons in a year RDF material in a good quality, smaller 25 millimeter. Here is also some picture from this plant. The other example is a slag treatment plant in Singapore. It's one of the biggest plants in the world. It's more than 600 tons in a year. And we separate from this material more than 10% ferrous and then non-ferrous metals. It's a special technology. It's a very nice plant near the sea. Okay. So the other solution from our company is the biological drying. It's in Iraq, for example. it's a simple but very interesting technology to produce RDF material or compost. We see it later a little bit more from this. Here's the other compost plant from our company with anaerobic part and the aerobic part. So now we see some example from the biological treatment. This is the simplest solution with a windrow turner. We have built in the last 20 years more than 1,500 machines in this kind, and we have the fine fraction from MSW or from biological material, and we turn this material after 3 days and give the air inside the material, and then we have a good rotting process. It's a simple solution. This is a better solution with tunnels. And we have also the tunnels for composting, and we have use also special tunnels for fermentation system. We have a tunnel filling system with a conveyor system. The conveyors goes inside to this side and then to the other side to the composting tunnels. This is the system we talked about it to close the windows with a membrane. We have one membrane to produce composting material, and we have the other membrane for a drying material and produce RDF material. I said we have the solution for fermentation to produce biogas here is and produce energy. And for all systems, we need visualization and then a control system. Here's an example for 8 tunnels. So, okay. Here we see some example from the machines from Eggersmann. In the first, we have the bag opener. We make more than 600 bag openers for the bags. Also a little bit special for bags for biological material, the ballistic separators, dosing bunkers, screens, and so on. We see a little bit more. We have shredder with this one wheel. It's a pre-shredder with 550 kilowatt. We have the machine in a mobile system and also as a stationary machine for complete plants. So, and for other kinds of material, we use machine with 2 wheels. It's very good for wood, for green waste and so on. So this is the bag opener. It's a walking floor system inside. It's the first machine in a lot of plants, and in the front is a big drum to open the bags, and when we can start with the sorting process. Here are 2 from our screen drums. We built it a lot of years, and we built drums up to 3 meter as a diameter and 14 meter in the length. So big drums. What is das? Das war das falsch. Sorry. Ist das? Yeah, okay. So the next machine is the ballistic separator.
Cara, eu tenho, porque na verdade, cara, eu tenho um curso das 16 das 4 às 6 da tarde.
Oi, pessoal. Oi. Vocês podem desligar o áudio, por favor, que a gente está ouvindo aqui?
Pode ser.
Ok.
Você quer vir aqui? Isso aqui.
Have you questions?
No.
Okay.
No, somebody is just talking with another.
Okay. The next is a ballistic separator with the machine. We use it for in a sorting plant, in a mechanical plant. We can separate with machine elastic material, light material, how foils or paper. And in the other side, we say the 3D material. It means material with 3 dimensions, for example, plastic bottles, stones, wood, and such part. And after it, we use a lot of optical sorters and can separate the materials, or we have 2 different materials for sorting by hand. This is a wind shifter. We have a lot of different wind shifting systems with this wind shifter to produce a lot of material for incineration process. So here you see the windrow turner. It's a big wheel in the inside, and we go with the machine through the material and give air and water in the material for a good performance in the watering process. In our company in Germany, we build also a lot of conveyors, more than 600 conveyors in a year. And I think it's important in the recycling area, you have special conveyors. It's not the same how in other parts from the industry. We have, you see here, 6 different parts. We have a little bit more, and I think it's a little bit special. You must know what you do in this part. We make also the acceleration belts for optical sorting systems. We have belts for light material. We have belts for very heavy material, for fine material, and so. Dann kommt das immer wieder rein. I don't know exactly what is this. Sorry. This is the one mobile screen from our company Terra Select. You give the material with a wheel loader in the machine, and you can make 2 different sizes from the material. Here you see the manufacturing from some machines in our company. Okay, and in end of May and the beginning of the June, in the first week, we have the fair trade in Munich. And if you would speak with us, please come to Munich, and we can talk about all details. Okay, this was the first. I think this is one example for a mechanical treatment. We have a lot of plants. This is a example from a plant for light packaging. This is the idea for a plant in Brazil. We can make a lot of different plants. I say something to this idea. We have area for the input from MSW. We have a shredder in the first part. Here we see a overbelt magnet to separate the ferrous in this box. And the next is screen drum, big screen drum. We make a fine fraction in the first part when we have also a magnet and separate a second time the ferrous from the fine materials and go with all other material to this box. Fine fraction means we have material from here. We have materials from 0 to 80 millimeters, and we can go from this box to a biological treatment. So we have also from this drum two conveyors to 2 ballistic separators. With the ballistic separators, we separate light material and give this material to a secondary crusher and make RDF material for incineration. The 3D, the heavy parts, and then the material with 3 dimensions, the most are the plastic bottles, go this way from here to here, and we have here completely 4 optical sorters, and we can make with the optical sorters, for example, PET, PE, PP, Tetra, and so on. This is a good material. For the idea, we have PET with an impurity from 85–92%, and here we have a sorting cabin to make a better quality by hand. After it, we have a quality from 95%. For the biggest parts from the input, we have the overflow from the screen drum and give this material to a sorting cabin. And in this part, it's okay to separate it by hand. For example, tires, for example, big foils, big cardboard. All other material go also to a big ballistic separator, and the light particles from this material go also to this shredder for RDF material. So in the other side from this machines is a eddy current separator. He separates non-ferrous and it goes to this conveyor. Here we have the bunker on the underside and push the material with a wheel loader to this conveyor, the baler feeding conveyor, and make bales. One problem in Brazil is we have all material in one bin, and the material had a lot of biological organic material, and when we have not such a lot of material for recycling, we must look a little bit more. Okay. Have you a question to this part? No? Okay.
Yes, I have one for them. We just said that at the mechanical separation, you can increase the quality through manual sorting, and then use it a number of 95%. I didn't understand this number. It means that the rescue of the fractions is going to be 95%. I didn't understand what you mean, 95%.
Okay. We see it in the next a little bit better, I think. In Brazil, we have an input material with a lot of organic material. And that means that we have in this box for the fine material 60, 70, 75% from the input. We have in this material not such a lot of material. PET bottles is 1%. Other bottles are 2 or 3%. We have a little bit paper, but it's on cardboard, but it's not very good. It means we have a lot of investing in this part, and we have not such a lot of recyclables. I think we must look for the organic material. This is
Yes,
important.
I understood. We are our average value from organic fractions goes from 45 to 55%. It's
yes,
the average value. And I also would like to hear you a little bit regarding to the first equipment, because as we are not very, we don't use things. We use mostly plastic bags, and at the plastic bags we put we introduce other plastic bags. I would like, can you talk a little bit about the first machine to open the bags, because you just talked about the open bag machine, but I think when you talk, we are discussing MSW. That's not selective collection. We must need Sharida. I don't know the name in English. I forgot.
Okay.
Can you talk a little about these two first machines that
in this area? We must open the bags. It's clear, no? And we have two solutions. They are in the near. We have one machine. It's the bag opener. We open the bags, and in the screen times we empty the most material from the bags. No? But we have big material. It's good to separate it the big parts by hand. It's okay. So if we would make a lot of RDF material, then it's better to use a pre-shredder in the first step. No? The material that you open also the bags, and the material is a little bit smaller. No? It's both solutions are possible. No? It's not a big difference. No? What I mean with the 95%, it's upper part. We have input material with 1% PET bottles. After the screening, we have a better material, and on this both conveyors are not very big parts. They are here, and we have not very small parts with a lot of organic. We have here better material. With the ballistic separator, we have we separate to this side film and cardboard. We have a fine fraction on this, and we have here a fraction with a lot of bottles. It's better. After this part, we have here the first optical sorter. We have here a conveyor. It's a high-speed conveyor with 2 meter wide, and the bottles are so and here we have a sensor system over this, And the sensor said with system or the system separates, for example, all plastic bottles. All plastic bottles go to the next machine, and this machine separate automatic PET. This ProteGEEr. So, and it means after this steps, we can say the input from this conveyor is a material PET bottles, for example, with near 90% impurity. And 1 or 2 person on this conveyor separate the last residues. And in the overflow from this conveyor, you have 95% impurity from the material. And the same you have it is in the PE, Tetra Pak, and so on. Okay. What I said, we must look to the fine material, to this with a lot of organics. And we can see here. I have some information to biological treatments from our company. This is a typical input composition for a lot of countries in the world. I think also in the near from the material from Brazil. Here's the performance by mass. We have organic material, 75%. It can be 57%. It can be 55, 60, 65. With a high water content. It's a wet material. We have paper and cardboard, typical 7, 8, maximum 12%. Also with a water content from the organic material. We have ferrous, 1% in Brazil, some other countries 2%. We have non-ferrous in Brazil 0, in other countries 0.5%. Glass in the near from 2%. Plastic, it means plastic bottles and so on. Near all plastic bottles 6%. Film foils, it's typical 7, 8, 10% from the input material. Inert material or ash, it's a little bit different. It's from 2% to 5, 6%. And other combustible materials, it's in the near from 8, 10%. In this range, we can speak about a typical material. We have a lot of material with this organic. This is a flow sheet, I would say, from a classic plant in Germany for waste and so on. And it's in the most part the first what we discuss. It means we have an input from MSW. And in the first step, we have in all plants a mechanical treatment. So it can be small, it can be big, it's different. We can separate recyclables. In Germany more, in some other countries not such a lot. And it's possible in this part to separate materials for incineration. We have mixed materials, for example, bed foils or wet paper or so on. It's not okay for recycling. But it's a material for incineration. We can separate it in the first step. When we look for the biological treatment, the green part means the biological treatment. we have a lot of questions for fermentation. We can do it, we make it, but it's a difficult technology. In this part, we can separate biogas and energy. We need, after the fermentation, in all parts, a next step, a rotting system, an anaerobic system, a composting system. And we need material from the mechanical treatment directly to the composting, and the other part from the fermentation. It's 50-50 with two parts. In the rotting system, the composting, we have water and a rotting loss from the material, and the stabilized material can go to a fine treatment. If we make a fine treatment, we have two parts. We have residues, stones, glass, and so on, film, foils, plastics, and we have a stabilized or a compost. It's you must understand it's a very simple compost. In Germany or Middle Europe, we have not such a kind of MSW. We have separate bins. That's why we can make in our plants a good compost. We have countries, for example, Iraq, also in the Arabic world. In these countries, we make a simple compost. It's not a good compost. And in this compost are a little bit of glass, a little bit of plastic, and so on. We cannot separate all parts from the compost. I think it's not the best solution for Brazil. You have compost from other parts. That's why I think we can have some better systems for Brazil. But let's talk about this. The first step is fermentation. We can see it. This is one part for fermentation. Here's a tunnel. The material goes in the tunnel. We have, for example, 10 tunnels in this area, and we can produce in a difficult process biogas. We have a storage, and we have a machine to produce energy. But it's difficult in the first step and also in the operation. You see here such tunnels for producing from biogas, and here is the storage for the biogas, for example. So, but what you must know, we talked about it was an example for dry fermentation. In the world, you can see also a wet fermentation. Wet fermentation is only for products from agriculture. It's not a good solution for waste. You have a lot of problems with waste in a wet fermentation. For example, with heavy and light particles. That's why our company make only a dry fermentation for waste. We can produce biogas, we can produce energy. We have more than 20 references in Germany, in Poland, in Bulgaria, in Switzerland, and so on. But this technology is very expensive. It's difficult. In Germany, it's possible to use this technology. That's why we have payment for electrical power from 15 euro for 1 kilowatt. So, and you need in all parts a combination from a fermentation with a composting system. Okay. So it means after the fermentation, you need the composting and in the most part, a fine treatment. So that's why we can talk about other system. We think it's a better system for Brazil. It's simple. It means in the first step, we can make a mechanical treatment, and we can also separate some recyclables. And the most material goes completely to the next step. It's a composting process, and we use the energy in the material for drying from the material. We saw in the first step, the material is very wet. And we use the energy from the organic material to dry this material. We don't need other energy. And we separate a lot of water and a little bit rotting loss from the organic material. And when we have a good material for incineration, for RDF material, we can make a treatment for this material, for separate materials for incineration. And we have also stones, glass, and so on for landfill. Here you see with two systems. We have, for example, rotting systems, composting. In the end of this process should be compost. It means we have a long process. For example, 28 days in the first step. In the most plants, we have second step with longer time. And here, the blue line is the water content from the material. And you must give water in it for good rotting process. The goal is to make a stabilized material with a good rotting. With the same technology, with the same technique, we can make a biological drying. It means we make in a short time, for example, 10 days, the water content from big to low. It means in the first 2-3 days, we make good conditions for the biological process. And when the temperature is higher and the biological process is very active. And when we have plateau phase, and in the last days, the goal is to have a low water content from this material. This is from the biological drying. The goal is a significant reduce water content of the material. What is the principle? We use aerobic microorganisms, bacteria. The bacteria are in the input materials, and we create only good conditions for the bacteria. It means we have level from the water content. We need level from the oxygen content. We need temperature level and good permeability for air. Here we see the input material in such a process and the output material. The input, for example, 10% inert material, stones, glass, and so on. 15% plastics, small parts from foils, and so on. And when we have 25% organics with 50% water inside, it's a typical material for this. during the drying process, we reduce the water from 10% to from 50% to 10% in the output material. We lost a lot of water in this process. It's go by a biofilter to the air, and we use a little bit from the organic material, for example, 10% for the energy from this process. And here you see the output material. We reduce it. Important. The inert material is the same, 10%. The plastic material is the same. We have a dried organic material, and we have 10% from all water in the material. And this is a good material to produce material for incineration. In the next step, we must separate a little bit from this inert material, and then we have this part from incineration. Here we see some example. This is the simple solution with the windrow turner. This is a better solution with a membrane. We give the material in this area by a wheel loader. We have on the underside a system to give air in the material. And here we have the membrane to reduce rainwater cannot go in the material, and the water steam from inside the material can go to the outside. You see it here. And when we use such a turner for this material, and after 4 or 5 days, we go with the machine inside the material, turn it, and the membrane goes a second time to the material. And after 10 days, we have a dried material inside. And when we give it to a mechanical treatment, you see it here in the backside, it's a simple solution, and can produce material for a cement factory or so on. Here's an example. The material goes to a cement factory. This is a little bit big machine. The other solution, we use it a lot of times in Germany, rotting or drying tunnel. With a system with underfloor with nozzles, and we close the tunnel with doors. Here you see the dimensions. The tunnel is normally 30 to 40 meter long, 6 to 8 meter in the wide. This is a ventilation system. For each tunnel, you need 2 ventilators, and we use in this system fresh air and make also the circulation. It's the question in this process. Are we in the first step? We make a recirculation when we have more temperature in the material, and if the process is in flow, when we give material to the outside, the water must go to the outside. Here you see some picture from the building from the underside from this tunnel. You see it's not very simple. We have in the floor such pipes and such nozzles to give the air inside the material. And the last step is to use a biofilter for a good air in the near from such a plant. In all plants and in all systems, we need the control system. It's automatic systems. The company Eggersmann has built a lot of plants, and when we have the programs for the control from with zebra from such a plant, with control from oxygen, from temperature, from water content, and so on. And when we have an automatic system for such plants. Here's an example from rotting tunnel. Okay, that's what I have to say. What questions do you have?
Wolfram, thank you very much. It was a lot of information. We have 2 classes that they are watching with us, from Professor Picanso and Professor Ronaldo from Fortaleza, Ceará, where you have already talked with them. I would like to ask the people that are with to take the chance to ask from about the experience, the technologies that we just saw, and I think we should start that. And you can be free to ask if somebody is shy to ask in English, you can say in Portuguese and then make the translation. There is no problem.
Cris, tem uma pergunta no chat, não sei se você viu.
Não vi.
É da Maria Helena.
Um minutinho.
Uhum.
Helena, sie hat gefragt, ob die, so, wenn man so guckt, was die Kosten betrifft, ob die eine offene Kompostierung wäre auch interessant, wenn man so insbesondere weil es gibt hohe Temperatur in Brasilien, wenn man vergleicht mit Trocknung, Biotrocknung.
Ja. Soll ich auf Englisch sagen?
Yes, please.
Okay. I understand. The question was composting system and the dry fermentation. Composting system need more time. The dry fermentation is need, for example, 10 days, and the composting system 30, 40 days for the first step. The technology is engineer. I think a problem in Brazil is the rain. For a drying system, we need a roof in all parts or hall. But we need not such a lot of space.
Yeah, there is also another point that you just said that, okay, they look similar, but they are not, they don't have the same aim. When you are implementing composting, you should produce compost. Like you said, needs more time, and the aeration is also a little bit different. And if you are looking for bio-drying, you are looking for to reduce humidity, but you are not really changing the biological structure from the fractions. Yes. And then it's not the same aim. If you don't have, I can tell about Brazil, if you don't have a market for the compost, but you have market for the biological drying for biomass, then please choose for biomass production. Mm-hmm. And then this is also a point that we forget in Brazilian to look for. Why I'm producing this product, mm-hmm. And if the market's going to be able to consume everything that I'm producing, because if not, the material after treatment is going to go anyway to landfill. And then I think this is the main point also to choose technologies. Marilena, is it okay for you? Tá tudo bem, Marilena, em relação à resposta? Or do you need something else?
Não, eu entendi, obrigada. Só para adicionar que eu coloquei assim, financeiramente falando, eu acreditava que a compostagem seria bem mais barata do que o sistema de secagem. Aí, o que é que você acha, Cristiane, que é que ele acha com relação ao financeiro? Porque aqui, como a gente não tem nada, o mais barato é por onde a gente costuma iniciar, né?
Tá certo. She just said when we look for the financial alternatives, seems that composting is going to be cheaper than biodrying. And she said where she is at the moment, there is nothing, no technologies being applied, and then they should look for the cheapest one to start.
Also, ich sage mal auf Deutsch, Christiane.
Okay. Sie hat gesagt, dass die Finanzierung nicht die gleiche ist wie bei ihrer, was die Offenkompostierung betrifft, sieht günstiger aus als die Biotrocknung. Und da sagt sie, weil die in ihrer Region, es gibt keine Technologiemomente, und wenn man etwas anfangen, dann sollte man mit die günstiger dann anfangen.
Ja.
Weil, wer ist deine Meinung über das? Weil du auch andere Market gesehen hast.
Also es ist prinzipiell dieselbe Technologie. Das sind ganz minimale Unterschiede. Wir haben viele Anlagen, wo wir das in die eine oder die andere Richtung umgestellt haben in Praxis. Ne? Also in Polen haben wir zum Beispiel Werke, da haben wir mit Kompostierung angefangen.
Can you auf English speak?
Yes, okay. I think open composting system or composting system and a drying system, the technology is in the near. You can use it for both the same technique for both technology. It's not a problem. And we have plants in Poland. In the first step, we use the technology for composting. And 3 years later, we use the same technology for drying of material. It's the question: have you the chance to give material to an incineration plant? From the investment, I think the cost for a drying system is cheaper than a composting system. That's why you need, for example, if we talk about tunnels, we talk for the same input, 10 tunnels for a drying system and 25 tunnels for a composting system. It's the question from the time.
Marilena, tudo bem? É porque fica muito difícil comparar a compostagem extensiva, que é aquela que você tem só ali um galpão coberto e faz o revolvimento com as leiras, com esses outros sistemas mais intensivos. Mas, de qualquer forma, existem duas questões importantes na compostagem extensiva. Os custos são efetivamente mais baratos, você está certa. Contudo, você tem bastante restrição na escolha de área, porque o impacto, por exemplo, da emissão de odor é bastante representativo. E o tamanho da área também, a demanda por área também é muito maior. Então, são aspectos que não dá para se defender uma tecnologia ou outra, porque vai depender da aplicação dela e, como você próprio salientou, da própria capacidade de investimento. Então, foi importante essa sua observação e eu espero que esteja respondido, mas ele quer continuar mostrando um pouquinho a diferença entre as duas tecnologias, tá?
Certo, tá certo.
Okay, Wolfram, you can keep speaking.
Okay, I think we have for composting or for drying the same technology. It can be with technologies, can be with technology, and also tunnels. It's always possible. The important difference is the time. You need for drying 10 days. And you need for the first step from the composting system 28 days in the near, 25, 30 days and so. And it means for if you have 500 tons in a day and 350 tons in a biological part. When you need more space or more tunnels or for a composting system than a biological drying. The technology is the same. It's a little bit different in the ventilation system, and it's a big difference in the control and the visualization system. But it's only a little bit in the other parameters and in the software. This is important. But normally we can start with a composting system. It's not a problem. And we can change the system to a drying system or in the other direction. It's both is possible. Different must you see in the treatment. If you make a composting, you make a fine treatment with the goal to make a stability. You need a fine screen, you need a wind shifter, a cleaning system, and so on. And if you make if you would make RDF, you make a RDF treatment also with a wind shifting system to separate stones and glass and so on. And it can be you need a shredder. It's a little bit different, but from the biological system, it's not a big difference. Okay.
Okay, thanks a lot.
Wolfram, I don't know, vielleicht hast du dieses Video, wo man eine Vergärung und auch eine Trocknung in dieser Video da vom Eggesmann. Ich habe dieses Video, das ist ein bisschen altes Video, wo man zeigt, wie eine Vergärung funktioniert und auch die Trocknung danach.
Unterscheiden. Also ich habe das erstmal nicht. The question was if you can see a video from this. You see that's a lot in a video. But you must understand, if you make a fermentation for the producing from biogas, after this step we have a very wet material. It's very, very wet, and when we need a composting system for to produce a stabilized material or a simple compost. The combination from a fermentation with a drying system is not possible. That's why we have after this a very wet material, and it's difficult to start with a composting process. You need more fresh material, and also if you have a look to the energy, you can use the energy as a biogas or as a material for incineration. You cannot use it in both systems. It's the same energy inside the material. No?
This is important, Wolfram, because there are some projects in Brazil that they plan with a fermentation, and after that, biodrying for biomass as RDF.
You cannot do it. It's not. It's very, very expensive and it's not okay. All energy, if it goes to the biogas, is not in the output. And if you make the rotting process, you lose energy. Was heißt Kohlenstoff, Wasserstoff auf Brasilianisch?
Gas carbónico.
Das ist hier im Biogas
CO2.
und dann nicht mehr am Endprodukt.
Yeah. Gabriel Stark, he wants to ask something. Please, Gabriel.
Hello, good morning. It's not exactly about the technologies, but just would like if he could talk a little bit more. He talked about difference of countries, like because of the management of the waste before getting into the plants. So just a little bit more of the importance of this and the challenge. What's important, like in a country of Brazil, that for sure is the management is different than Germany. So the importance of this, all these steps before, like since citizens at home, the collecting system, this challenge importance to get to implement these technologies, and also about the scale, because like in Brazil, it's really big country, a lot of small cities, and also huge urban areas. So the challenge of the scale to implement some technologies also.
I talk a little bit about the German system. German is a little bit too much. We have different bins. For my house, I have one bin for only for biological material. Have one bin for packaging material, for light materials, for foils, for plastic bottles, and so on. I have a bin for paper and cardboard, and I have a bin for the all other residues.
Yes.
All
And do you
material.
clean it before putting it into the bin?
What?
Do you clean it, like more or less the material before?
No. I separate it. It's okay, but I don't clean it. No? But so we have in our town some sites for a class, and also I think it's important. We have on one place in the city we can give to this all big parts, furnitures and so on, and also batteries, color, oil, and so on. I think this is important to have a chance to separate this bad materials. And I pay this system, this the payment from my bins in at house at home. If you the sum from the total from all material in Germany, it's near the Brazil. It's only we give it to different bins. Yeah? But I think this is expensive system, and we have in some other countries in Europe, step by step, we have separate collections for some kinds of waste. It's okay for paper and cardboard, for glass. For light packaging, it's I think it's not the best system. In all other countries from the world, in Iraq and Brazil, and we have maximum one bin or bag for all kinds of material. It's normally in the world. And I think the first step must be to use this material in a plant. And step by step, you can make it different. I think the first step must be make a collection system for batteries, for oil, and for colors. This is important for me. The next step can be collection for glass and for paper and cardboard. Yeah. And then the paper and cardboard from one complete bin is not good. It smells and so on.
Wolfram, please speak about the cost of the treatment. It's a necessary idea about.
I don't know exactly. We must look. I think I don't know exactly. I must look for you. It's interesting to use what do we need for 1 ton. I must look in the next step. But what can I say? For example, a mechanical treatment. For a mechanical treatment for 500 tons, you need 3 to 7 million euro. Yeah, it's different. Yeah? And for the biological part, it's for the same input for 2 or 1 million euro for this system, but you need a lot of space. It's 3 million for this system, and such a tonner, I think it's near 6-7 million euro. Yeah, but it's the better system. That's why I think that the best solution is such a system with a membrane. Yeah? It's a good system. It's not too expensive. A problem with the material in Brazil is you have not such a lot of good material in the input material. We can make a look. I have here a mass balance also for material in the near from your material with 60% organics and so on. And we go step by step through the material. What make a magnet? You separate, for example, from the iron 80%, and you can see how from the input is 0.7 tons and 0.6 tons you can separate in this step. So, and only we make it what is at the first screen, what make a ballistic separator and so on. And so we develop the complete plant. And what makes the NAR separators for PET. Here we can see it. For example, we have all material in the input to this machine. So, and we can separate 96% from the input material in this part, and we separate 0.4 tons in 1 hour PET material, for example. We look to the end from this sheet. For a typical Brazilian material, what can we separate? From the tires in the input, 0.8% from all material. We can separate a little bit big film. We can separate a little bit big cardboard. So, we have mixed plastic. We have mixed plastic from the automatic system, 1.5%. We have 1.2% PET. We have a little bit Tetra Pak. We have ferrous and a little bit non-ferrous. So if you make it all, we have 8% from the input material to separate with a lot of machines. And we can make 13% a pre-product for incineration. And we have 66% goes to a biological treatment. This is a normal situation with material from Brazil. That's why I said we must look to risk 66% from the input. That is important for me. No? I know all people say we would separate material, but it's not possible to separate more than 8 or maximum 10% from this material. No? Maximum. Okay.
Okay. Thanks. Good.
But and my other what I say from this 66% input for biological step, it's very simple to separate the half from this 33% water and rotting loss. It's very simple. Huh? It's cheaper to separate 8% from the mechanical part. It's
we have another question from Sarah. Sarah, can you make a question?
Yes. Good morning. Thank you for your presentation. I've been with Christiane and also Professor Ronaldo in Germany, in IFAT, and we have met Egesman there. It was a very good trade fair to know many different technologies, and we have seen that here in Brazil, the market is growing in this field of recycling industry and also many other waste treatments. But do you think that Egesman has any proposition to come to Brazil and work here and establish your technology and equipment also here? Is it something in the future for Egesman or not? I've seen that we have evolved in this sector here.
Udo, willst du was sagen?
I'm sorry?
I talked with a colleague, Udo. He was sometimes in Brazil. I also, I think 3 or 4 times. I think it's interesting for us. Udo, would you say something?
Yeah. My name is Udo Sunderbring. I work for Egesman and for 30 years. And I was in Brazil for 5 years ago in Sao Paulo for the sorting plant and for the composting and digesting plant. For my opinion is the first step is what you want or what can you in your country for this recycled material. I think Christiane.
Yes, I'm here.
Ja, kannst du mal übersetzen? Ich kann das besser in Deutsch. Ja.
Okay.
Also für mich ist der erste Step, wenn ich eine Anlage plane, das, was man mit dem Material machen kann, was dann letztendlich im Output erscheint. Kann ich es verwerten oder kann ich es nicht verwerten? Kann ich es kompostieren? Was für einen Markt habe ich in der Stadt?
O primeiro passo, isso a gente falou um pouquinho antes, durante a fase de planejamento de uma planta dessas, é entender qual que é o material que entra na planta e, efetivamente, de que forma o mercado vai se posicionar em relação a esses subprodutos que serão produzidos nessa planta. Essa é a primeira pergunta a ser respondida. Ok, Rabis?
Ja, also die Firma Eggersmann hat eigentlich für alle Möglichkeiten Anlagenequipment. Wir können also kompostieren, wir können Vergärung machen, wir können sortieren. Das Einzige, was wir nicht machen, ist verbrennen. Aber
a empresa Eggersmann tem uma série de tecnologias que permitem a valorização mecânica, a valorização biológica, seja na forma de compostagem, biossecagem ou mesmo fermentação. A única tecnologia que eles não dispõem é tecnologia de incineração.
wir haben also Anlagen gebaut für Hausmüll, für separat eingesammelten Hausmüll, also sprich in einzelnen Fraktionen, die wir sortieren. Wir können aber auch eine Gesamthausmüllanlage bauen. Die haben wir zum Beispiel in Israel, in Irak, in Amerika, überall schon realisiert. Es kommt immer darauf an, was wir letztendlich mit dem Output aus so einer Anlage machen können. Was der Kunde damit, sag ich mal, die Möglichkeit, die der Kunde hat, das zu verwerten.
Que eles têm experiência em diversos outros países, como o Iraque, o Vietnã e mesmo nos Estados Unidos, e que a decisão está sempre relacionada com o mercado que vai consumir esses subprodutos. Aber was die Sarah gefragt hat, ist, ob der Eggersmann hat wäre es die Vorstellung wegen der brasilianischen Markt, hat Interesse, etwas hier so in Brasilien zu gründen oder im Moment nicht?
Ob Firma Eggersmann eine Vorstellung hat, was für den brasilianischen Markt ist, oder habe ich das richtig verstanden?
Nein, wie wir uns engagieren wollen, Udo. I think the market in Brazil is interesting. It's clear, and then we was sometimes in Brazil. No? The problem for me is that we have very long times for some projects. I have projects for 5 years ago with 2,000 or 3,000 tons in a day with the incineration in the backside. And we have in this time, I think, the 6th or 7th solution, and we it's very difficult when we the process is stopped in this time. No? That's why it's right that Udo said. In the first step, we need some information to the market, and then we can make a first solution, and we can talk about the solution in the first time is our work in Germany, and when we come to Brazil, and we can talk about all details and start the process.
Okay, thank you. Somebody else? Okay, I think we can finish if we don't have any more questions. And I'd like to thank you, Wolfram, and also Udo for this presentation. And would you like to know if it's possible to have the presentation in PDF to send to the people that they were here watching you? And I would like to ask everybody to sign the presence list, and through the signature, we are going to have the chance to send the presentations from Dr. Wolfram. Then thank you very much. We see us at IFAT, and then we want, like Sarah said, we want to see you more time in Brazil.
Okay, it's good. We do it. It's a nice country.
Ok.
Thank you.
Obrigada a todos e todas, e até a nossa próxima nosso próximo encontro. Obrigada, professor Ronaldo, obrigada, professor Picanso, e a todos os participantes pela atenção. Então, um grande abraço aqui da Alemanha para vocês e até a próxima. Tchau.
Tchau, tchau.
Tchau, Udo.
Obrigado.
Tchau, Wolfram. Tschüss.
Thank you.
Ciao.
Bye.
Thank you.